With the power rule, remember we have a base raised to a power already, but then it's raised to another power. So multiplication is how we will simplify these. With x to the fourth being raised to another power, that means x to the 4 times 2, which is x to the power of 8. So you might be wondering, how does that really work? How do we know that that's correct? So let's break it down. X to the fourth we know represents x times x times x times x. If you square that, it means you have two identical amounts. So we would have another x times x times x times x. How many x's do you see? Well, there's 4 there and 4 there, so we have x to the 8th. Notice how it's the same answer, but it's a lot faster just to multiply. So at least you can see maybe why it works to multiply. Our next example has a numerical base. So I really don't want to say that 2 squared makes 4 right now, because then we just end up using larger numbers than what we really need. So I'm just going to go ahead and use the power rule. Our base of 2 is raised to the 2 times 3, which is 2 to the power of 6. Since it's a numerical base, we need to explore this more. 2 times 2 times 2 times 2 times 2 times 2. So we'd have 4 times 4 times 4, or 16 times 4, which is 64. Now, if we had gone a different way with this, if we really had said that 2 squared makes 4, then 4 would have been raised to the power of 3. And notice that's exactly what we ended up with here. 4 times 4 times 4, which is still 64. In the last example, notice we have a negative exponent. Well, there's no problem with that. We're still going to apply the power rule. Our base of 5 is raised to the negative 1 times 3, which makes 5 to the negative 3. Now we know we can't stop here because our exponent is not a positive number. So we have to apply the negative exponent rule. Think of 5 to the minus 3 as being divided by 1. So the base of 5 to the minus 3 shifts down into the denominator. When that happens, we have 1 over 5 to the positive 3. Since 5 is a numerical base, we really need to think about how much 5 times 5 times 5 is to get to the final answer. So that makes 25 times 5, which would be 125. So 1 over 125 is our final answer. With the power of a product, we have more than one base being raised to a power. So each base individually is raised to the power. In our first example, we have a base of 2, base of x, base of y. So don't forget that the numerical coefficient also has to be raised to the power. So we would have 2 to the 7th. X to the 0 times 7 is still 0. And then y to the 5 times 7 would make 35. Now we need to keep going because 2 is a numerical base. And since we just found out that 2 to the 6th, 64, so 2 to the 7th would mean we have one more base of 2. So 64 times 2 would be 128. So 128, x to the 0 is worth 1, so that's eliminated, and we just have our base of y. So 128 y to the 35th. Next, we've got 3 raised to the negative 3, a to the negative 3, and b to the minus 5 times minus 3. That makes positive 15. So it looks like we have some negative exponents here. Think of these terms as being written over 1. That way, anything or any base written with a negative exponent will need to shift. So that means 3 to the positive 3 in the denominator. A to the negative 3 also shifts down. So it's a to the positive 3. Notice b to the positive 15 remains in the numerator. So our only step remaining is to simplify 3 cubed. So that would be 3 times 3 times 3. So that's 9 times 3, or 27. So 27a cubed is in the denominator, and b to the 15th is in the numerator. The last example here, each of these bases is raised to the positive 3. 4 cubed, z to the minus 9. I notice I have a negative exponent, so I want to be thinking of division of 1 just to help me track what needs to shift. 4 cubed is okay in the numerator. Remember, this means 4 times 4 times 4. So 16 times 4 is 64. But the base of z needs to shift into the denominator as z to the positive 9. And that's all we need to do for that one. With power of a quotient rule, we're starting with a fraction raised to a power. Notice the parentheses. That means the numerator is raised to the power as well as the denominator. So we have parentheses with 2/7 raised to the power of minus 2. So that means 2 is raised to the power of negative 2, and 7 is raised to the power of negative 2. Since these powers are negative, I need to rewrite 2 to the minus 2 is shifting to the denominator. 7 to the minus 2 is shifting up to the numerator. So their exponents now have become positive, and we can simplify this. 7 squared would be 49, and 2 squared makes 4. Do 49 and 4 have any common factors? If not, that's the answer. Working with variable bases, we're simply applying the power rule to both the numerator and the denominator. So y to the negative 8 times 5 would be y to the negative 40. Y to the negative 3 times 5 would be y to the negative 15. So each of these bases is raised to a negative power. So if you wanted to rewrite them with positive exponents, you could. You really don't need to do that step, but now I would say compare the numbers 15 and 40. Remember, whichever one is the smaller one is the one that needs to shift to get to the final answer. 15 is smaller, so y to the 15th is shifting down, leaving y to the 40th times y to the minus 15 in the denominator. So that would be 1 over y to the 25th power. In our last example, we have a numerical base, and we've got bases of x, y, and z. So every base, including the numerical base, is going to be raised to the power of negative 2. So I have 3 to the negative 2, x to the minus 4, and y to the minus 2. In the denominator, y to the negative 9 times negative 2 makes y to the 18th. And when I'm writing out these bases, I'm trying to line them up to make it easier to see where the like bases are. Z is also raised to the negative 2. And there were no other bases of z yet, so I created a whole new column for that. So I can see that 3 is my only numerical base. It's raised to a negative, so it's in the wrong location. I'm going to shift that to the denominator. X is the only base of x that I have, but it has a negative exponent as well, so that needs to shift into the denominator with a positive 4. But base of y is written in 2 places. Remember that only the base that has the smaller exponent needs to move. Comparing minus 2 with 18, minus 2 is the smaller one, so that's going to shift down, as a positive 2. So I'm going to have y to the 20th power. And finally, notice z to the negative 2 has a negative exponent, so that needs to shift to the numerator with a positive exponent. So the only thing left to figure out is 3 squared. That would really be 9. So I could write 9 right now. Z squared is divided by 9, x to the 4th, y to the 20th. So just make sure that each base is written only one time and each base should have a positive exponent.